Impacts and collisions 2019, question 5b. A smooth sphere P of mass 2m collides with a smooth sphere Q of mass m. The velocity of P is 3ui plus 4uj, and the velocity of Q is minus 4ui plus 3uj, where I is along the lines of centers at impact. The coefficient of restitution between the spheres is 5/7. So we're asked to find two things. In terms of u, the speed of each sphere after collision, and the angle between the directions of P and Q after the collision. And we were given a diagram. And this is my diagram. So let's look at before and after based on the information that they give us. So we have 3ui for P. We have a mass of 2m, and we have velocity of 3ui plus 4uj. Now we know within oblique collisions, the j direction isn't going to change. It's just the I direction that changes afterwards. So after, P is going to have a velocity times I, and it's going to have the 4uj. And similarly with Q, there's going to be a velocity times I. And let's have a look at the mass. The mass of Q is m. And we have a minus 4ui, which will change, and plus 3uj, which won't. So we can fill this information into our two formulas. Let's look at the conservation of momentum. So we're talking about m1 u1 plus m2 u2 is equal to m1 v1, and the dog barks in the background, plus m2 v2. So we have 2m by 3u plus m by minus 4u is equal to 2m by v1 plus m by v2. So cancel your m's. So we're left with 6u minus 4u. So 2u is equal to 2v1 plus v2. Okay, Newton's experimental law. v1 minus v2 over u1 minus u2 is equal to minus e. So we'll write it as v1 minus v2 is equal to minus e times u1 minus u2. So I just have my v1 and v2 in terms of v1 and v2. I have my e. What did they tell us e was? 5/7. So minus 5/7 times the initials, 3u minus 4u this time, so plus 4u. So we're going to get 7v1 minus 7v2 is equal to minus 5/7u, so minus 35u. And you can see that there's no common, we can divide by 7. v1 minus v2 is equal to minus 5u. So we have a negative v2, and here we have a single positive v2. So bringing this down, I'm going to get 2v1 plus v2. 2v1 plus v2 is equal to 2u. So we're going to get 3v1 is equal to minus 3u. So v1 is equal to minus u. I'm filling that back into one of my equations. Take this one. v1 minus v2 is equal to minus 5u. So we have minus u minus v2 is equal to minus 5u. So v2 is equal to, well, we'll leave it as the minus just to see, v2 is equal to minus 5u plus u. So v2 is equal to, or minus v2 minus 4u, v2 is 4u. So that's v1 and v2 in terms of u. Now we were asked for the speeds, weren't we, in part 1? The speeds in terms of u, the speed after the collision. So we just write down what they are afterwards now. Now we can do it up here beside the after. So for v1, we got minus u, so we're going to have minus u times I. plus 4u times j. And v2, we got 4u plus 3u times j. Now the speed we know, so for p, we know we get the square root of minus u squared plus 4u squared, the coefficients of square root of 17u squared, which we could write as the square root of 17 times u. So for q, what do we have a 4? Well, we can see it's a 4 and a 3, so I'll do it down here. Q, the square root of 4u to be squared plus 3u to be squared. And that's like my 3, 4, 5 triangle, so the square root of 25u squared, which is equal to 5u. So they're the speeds in part 2 they're looking for. The angle between the directions in P and Q after the collision. Okay, the angle between the directions. So let me just write down the velocities again afterwards. So we have minus u minus 4u minus u times I plus 4u times j. And for Q, it was 3 and a 4, which direction? 4ui plus 3uj. Okay, so let's imagine that they hit at this point. Now, what direction does each go in? P goes minus plus, so minus u plus 4j, if we imagine it like this. So Q goes 4ui plus 3uj up in this direction. So if I put my values on here, I have a 1 for my minus u and a 4. And I have a 4 and a 3. So we're looking for, well, sorry, it's the angle between them, not in there. The angle between them is going to be in here. So if I can get both of these angles, just add them together. So it's inverse tan. And you can see that this triangle will also have a 1 and a 4. And this triangle here will also have a 4 and a 3 along here. So let me just look at this angle. I'll color it in. We'll call this one A. So the tan of A is equal to O over A, which is 1 over 4. So the inverse tan of 1 over 4, just type it into your calculator, you're going to get just over 14.04 degrees. In this one, angle B, opposite is 4 and adjacent is 3. So the tan of B is equal to 4 over 3. So B is equal to the inverse tan of 4 over 3. That's that really common angle, 53.13 degrees. So A plus B is the angle between them. What's that going to give? 67.17 degrees? 67.17 degrees.